Okay, so this video was going to be about the Hooke's Law lab, but as I got everything out, I noticed that we're missing a few things. One I knew already is that one of these guys got damaged, and it's no good anymore, but there are still 5 of these, including this one here, 4 plus this. The real problem is these guys. And of course, Hooke's Law is all about the springs, and here are the springs. There's 2 of them. And I have no idea at all where the other 4 of these guys are. We have everything else here, and we have the hanging masses, we have the bases, we have the uprights for the lab. Look like this. So I mean, I'll show you how to put it together briefly, but I'm going to then point out a different way that you could do this lab instead of this neat setup kit thing from what is it? Science First. From Science First. Okay, I'm going to pause this while I set it up. Alright, so I just attached the arm into the base. You don't screw it all the way in. You just use this nut to tighten it down once you get it in a ways. This would be the scale. Interestingly enough, this is not actually centimeters. It's just a bit off, which is another reason that maybe this isn't the greatest thing to be using in the first place. To hook this, to attach this, you would put this guy through this little hole here, like so, and now it's attached. And then there's a bigger hole up here on this, right there. So we would take this and put it through there at the top. And that is the setup. So at this point, you can see the this little needle, which will move as the mass goes up and down, or as you add mass to it. So yeah, let me get the mass out. All right, so I always start with one mass already on the thing, because that gets the spring just a tiny bit stretched out. If you don't do that, then the first data point ends up being off. So then what you need to do is get the whole thing steady, and then we would use the mirror scale, which I can move by pinching the back of it here, so it can go up and down. And then we would basically line up the image in the mirror with the actual thing and with the 0. So that's pretty close to 0 right there. And then all we would do is, as we took our data, we would add more of these masses, starting at the top here and sliding them down over the holder. Right, one at a time, take the reading, next one, take the reading, and so on, until we have 10 data points, and then we can plot a graph which shows the linear relationship of Hooke's Law. Yay! But like I was just saying, we're missing 4 of these springs, so I don't think you can actually do it this way. Instead, I would suggest that you find a way of using these guys. And you could even do this, since these are all different scales of measurement, you could actually do this lab. You could do the Hooke's Law lab using several different springs with different scales on them. And then you could use the hanging masses, these guys over here, in order to measure the force that you're applying to that. Now, obviously, these are labeled. These are you know, force probes. These are force meters, right? The old style of force meter where you can pull on it, right? But it's also just Hooke's Law. I mean, you can show why these work as a measurement of force because it's Hooke's Law with the spring that's inside there. So you can show how far it moves for each added amount of mass. You just have to measure the distance that it moved using some kind of you know, maybe the calipers, which are right there above us. You could either use the calipers there, or you could just use a ruler and figure out how far it moves for the amount of mass you added. And you could use different, I mean, there's different, each different color in here has a different spring inside, and therefore a different spring constant, and therefore a different amount of movement for the amount of weight that's added. So yeah, I mean, these are spring scales. So there could easily be a lab designed to use these guys for Hooke's law instead of using the other apparatus, since the other apparatus is just not complete anymore. Anyway, the other apparatus gets stored in that spot right there. So these are the force gauges right here. All right, that's it for this video.